Now that we've conquered parallelograms and triangles, we're moving on to other polygons. Today is just about trapezoids and throw in some mixed review at the end. Trapezoids, we learned in chapter 6, were quadrilaterals that had one pair of parallel sides, opposite sides, that were called bases. When you find areas of trapezoids, you really have two options. One is to use formulas that you already know. So you can use rectangle formulas, parallelogram formula, triangle formula, because all trapezoids can be chopped up into rectangles, parallelograms, and or triangles. So as long as you know your parallelogram and triangle formulas, you really can do anything that's non-circular. So we're going to start with that method and finding the areas with the formulas that we already know, and then I'll show you one special formula for trapezoids. The catch to that one, of course, is that you have to memorize an extra formula. So they like to give you, especially on standardized tests, things with right angles in them, which are best chopped up into easier figures. So we have a trapezoid here, and I'm going to chop it up into two separate figures, a rectangle and a right triangle. Now when I chop that up, I'm going to have a triangle with a leg of, well, let's break this up. We got 5 meters here, and 8 plus 8 minus 5 is 3 meters here. So this is a 3, 4, 5 triangle, one of our Pythagorean triples, and we want to keep our triples in mind because they pop up pretty often anytime you're working with triangles or figures with triangles in them. And we're going to find the areas of the rectangle and the triangle separately and then add the two together. So let's start with the rectangle. Area of a rectangle is base times height, and the base of the rectangle part is 5 and the height is 4. So 5 times 4, which is 20, is the area of the rectangle part. Then we have the triangle over here. Area of a triangle is 1/2 times base times height. Base and height have to be perpendicular. They need to make a right angle. So that means this hypotenuse of 5 is useless. We do not need it. We do need the 3 and the 4. Order doesn't matter. 3 times 4, 4 times 3 give you the same number. So I'm going to do 3 times 4. 3 times 4 is 12. Half of 12 is 6. You should not need a calculator for that. If the numbers get uglier, by all means pick up your calculator to do the multiplication, but most of the time you can do it without a calculator. So we have a piece that has an area of 20 and a piece that has an area of 6. When you add those areas together, you get a total of 26 square meters of area for the whole figure. Okay, the next one is turned sideways. Still a trapezoid, one pair of parallel sides, and if we chop this one up into a triangle and a rectangle, the rectangle is 15 by 7, so its area is 15 times 7, and if you need a calculator for that one, then by all means pick up your calculator and do 15 times 7. If you can do that without a calculator, that's even better, but it actually turns out to be 105. And then the triangle, well, let's see. From here to here is 7. From here to here is 8, because 7 plus 8 is 15. And this dotted line is 15. This is an 8, 15, 17 triangle. That's one of our Pythagorean triples. Sometimes you won't be given all the pieces and you have to figure them out for yourself. So then we need for the triangle 1/2 times base times height, so 15 times 8 or 8 times 15. You've got to take the two sides of the triangle that make the right angle. So the 17 is useless. Don't use it. So 8 times 15. Alright, so half of 8 is 4. 4 times 15 is 60. So this is equal to 60. So we have a piece that's 105 and a piece that has an area of 60. So the total area is 105 for the rectangle plus 60 for the triangle, which is 165 We're in meters, so meters squared for the total area. Pretty much any figure that doesn't have curves in it can be chopped up into triangles, rectangles, parallelograms. As long as you know your rectangle/parallelogram formula and your triangle formula, you can always pick it apart. Now, sometimes there's some missing measures that make it hard to use those formulas, but typically on a standardized test, they're going to give you all the measurements you need, with the exception of occasionally they'll leave out a measurement like this 15, and you have to use a Pythagorean triple to find the missing measurement, which is why you need to know these triples that pop up a lot. Okay, let's take a look at the second method. There is a formula for area of a trapezoid. The catch is, if you're going to use it, you have to memorize it, because it will not ever be given on ACT or even on my test. You have to have your formulas memorized for any areas, perimeters, or circumferences. So area of a trapezoid is 1/2 times the height, which is the distance between the bases, times the sum of the two bases, base 1 plus base 2. And the bases are the parallel sides. It's a nice little formula in that you can just substitute numbers in, do the operations, out comes an area. So you can do it all in one fell swoop. That comes in handy for a problem like this first one, where we have whole bases given, but to chop them up into smaller pieces would take a good bit more work. So this would be a nice one to use the formula for. So area equals 1/2 times the height. So the height is the perpendicular distance between the bases. They're not labeled, but we really should have some parallel marks on the 21 and the 41. Those are the bases. There should be a right angle mark here. So we're going to add those in since they were missing. Typically you wouldn't add your own, they would already be there. And 18 is the perpendicular distance between the bases, so that's how tall it is, that's your height. So 18 for the H. And then in parentheses, the sum of the two bases. So you could do 21 plus 41, or you could do 41 plus 21. It doesn't matter, the sum is the same in any order. So 21 plus 41 will work just fine. Now, if you opt to do this without the calculator, then you need to make sure you add what's in parentheses first. Order of operations says do what's in parentheses first. So 1/2 times 18 times 62. Then you can do half of 18 is 9, and then 9 times 62 to finish it up. For those of you who are calculator fiends, you can do it all in one fell swoop on the calculator. So control divide will get your fraction template, 1/2. You could make that a 0.5 if you think it's easier, doesn't really matter, times 18, and then you could do times 62 since you've already figured out the sum of the pair in parentheses, sum of the bases. Or you can type in the original version if you want to skip writing this step down. You can do open parentheses and 21 plus 41. So it should look on the calculator exactly like it looks on paper, which means you need to make sure you write it down correctly on paper. So that's 558, which is the same thing we'd get if we did 9 times 62. So 558, we don't actually know what the units are, so we'll just say units squared for a generic unit for that one. All right, one more and we are finished. Scoot that over. Now this one, we have some things unmarked. We have a right angle in sort of a funny place here. There should be a little more dotted line right there. Dotted lines in geometric figures indicate measurements related to the figure, but they're not actually part of the figure itself. So really this figure outlined by the solid line is what we're trying to find the area of. And that is a trapezoid. It's not marked, but the 8 and the 14, those are parallel sides. If you find it hard to look at in this orientation, it's really easy to fix. Turn it around and look at it this way. Your paper will turn. It doesn't take a lot of work to do it. So if you want to look at it from this perspective, 14 and 8 are the bases, and the perpendicular distance between them, the right angle distance between the bases, is 11. So 11 is our height. And then we substitute into the formula. So area equals 1/2 times the height of 11 times 8 plus 14. And we can either multiply manually and get our answer, or we can use the calculator. For those of you who are pretty savvy with your addition and multiplication facts, 8 plus 14 is 22. And half of 22 is 11, and 11 times 11 is 121. You could do this without a calculator. For those of you who are pretty heavily dependent on the calculator, I'm going to have to shift this because the lights are glaring pretty badly. 1/2 times 11, open parentheses, the calculator knows to multiply there, 8 plus 14, and we get 121. So the area there is 121. We don't know the units for sure, so we'll just say square units and be done with it. Alright, so you're going to do the 10-2 practice worksheet today. It has a front and a back. Front side is all trapezoid questions. Back side is a mixed review of trapezoids and triangles, rectangles, and parallelograms. To keep working on those, and part of the battle is being able to take a look at the geometric figure, know what that figure is that you're looking at, and apply the correct formula. So it's good to mix those up and do different formulas all on the same worksheet, sort of scattered out. So do both sides of that worksheet today, and tomorrow we will move on to rhombuses, kites, and polygons.